Assalamu alaikum. My name is Moaz Ahmed and in this video I will be explaining the lab number 2 of microcontrollers subject. So in lab number 2 we were required to introduce ourselves and implement the assembly language on Atmega 328P using AVR Studio. So our first task was to take input from one port and display output on another port. So I have created the Proteus file here. So if I open the code, we can see the code right here. Sorry, in this task, our task in this task, we were required to define output on a register and then display that output from that register onto a port. And then we were required to add two different numbers which were stored in two different registers. Like if you notice here that first of all we are loading a value of 0xFF to R17 register. Then we are loading a value of 0001111, 00041 and 0 into R16 register, and then we are displaying the R17's value on DDRB register, which means that port B is now all of the bits of port B are output, as 0xFF has 8 all of 8 bits as 1. Then we are storing another value in our 18 register, which is 0b, which is a binary, which is code for binary, 000111101. And then we are applying the add operator on both of these registers, register number 18 and 16. And then we are displaying that value, the answer which will be stored in R16 on port B. And then we will jump to the start, displaying it again over and over again. So I will run this project from here. So now we can see that it is displaying us the output. So that's it from this task 1. Now let's move forward to our task 2. The task 2 of this lab is right here. So in here we have, first of all, we have defined the main tag after the start and original tag, and then we are storing a value in R18 register 0x00, which means we are going to declare the output C as input. Declare the port C as input, as we have done it right here. Output DDRC R18, and then we are storing 0xFF in R20 register, and we are declaring the output on DDRB. So let me just correct the syntax a little bit. Sorry, this file was corrupted. So I have already opened the file here. So this is the code which I was previously discussing, and R20 will be stored as I discussed it back then. R20 will be stored in DDRB, which means port B will be output, and then we are going to take input at R21, register number 21, from pin number C, pin C, and then we are going to display that output on port B. So let's get started. So if I will build this project, and I will I have already opened that file here where this is stored right here. So I will copy the name from here, and here goes backslash, and I will copy all of this, and I will go back to my Proteus file, I will open this and I will paste the link address here. And so now if I seems like there has been an issue, so we will come back to it later. Now let's move forward to the task number 3. This is task 3. I have already uploaded the code here. So first of all, we have declared the input and output, then we have declared the registers values, and then we have declared a loop concept, and in loop we have declared the port B as output, and on port B R28's value will be stored, which is this one. This code will be giving us a charging operation, like each bit will be on after its previous bit has been on. So let's say if we run the code, if I go here and I simply run the code, we can see that first of all this LED is on. After some time, the next LED will automatically turn on. See? And after some time again, the next LED will be on. This is like a charging device. The system is charging. So that's it from this task. Now let's move forward to our next task. So let me just close this. So this is our task here, right here. In the task, we are required to, first of all, we will declare port B as output using our 16 register, and then we will again declare port C and port D as output. So in this code, three of our ports B, C, and D are output. And then we have stored values in different registers R28, R29, R30, and R31. And then we are going to display R28 on port D, R29 on port B. And then we are going to compare R28 and R29, which means these two numbers will be subtracted. And if they are not equal to 0, then we are going to branch our code to this tag underscore any not equal. So if these two numbers are not equal, then it will move here and output port C. On a port C, it will output the value of R31. But if this line does not work and it is skipped, which will be the case if both of these numbers are equal, then we will show the R30 on port C. So if I go here and run the code again, so we can see here that both of these numbers are equal. That's why the value that is being shown right here is this one, 001100. So our code is working. And additionally, we had an other task that was to simply implement the traffic light system. So if I so the logic behind this code was when a green light at one signal is on, all of the other three signals have the red light. And when the green light is about to turn red, then the signal next to it will show a yellow light for some time later, being moved to, let's say, later being moved to green light, and then after some time it will revert back to red light. So if I run the code, so we can see that first it was yellow, then it has moved to green, and all of the other LEDs are red, and then it has turned to red, but this was green for some time before becoming red green. So this cycle will keep on moving as long as we want, because this code has been implemented in the forever loop. So that's it from the lab 2, and I will see you in the next video.